Alright, so now in this video I'm going to try to scoot through this pretty quickly. If you weren't here in class, we covered this, but I think in the video it's going to go a lot quicker than it did in class. So we're just going to concentrate on the concepts here. First thing, oops, already made a copy. Let me get rid of that. First thing we're going to do is duplicate the part studio. So in Onshape you can have multiple part studios in one document. So like this is just one, main project, and I can have multiple part studios inside here. The reason for that is one part can get pretty complicated. So if you're making multiple parts, it's probably the best to just start a new part studio and create that part in the same document. So we're going to, instead of creating basically the same thing, we're going to create a second half that looks very similar, minus one component. So we're going to duplicate the part studio, which will copy everything as it is that we see here. So I'm going to right click the part studio 1 tab, choose duplicate, and then I'm going to switch over to part studio 1 copy 1, and here is our main part. And the only difference we want to make with this one is to get rid of the thing that would hang the ornament from the tree. We only need one of those. So I want to get rid of this ring at the top. So in my list of operators over here, I need to find the one that creates that hoop. So there's going to be a sketch and then an extrude attached to it. Yours might be a different label. Mine is sketch 3. So it may be hidden. This is just the sketch. And then from the sketch I made the extrude. So I'm going to get rid of the extrude. So you could either select it and press the backspace or delete button. That didn't work. Just get rid of both. And you'll see it creates an issue here because it was part of the solid that was used. First they were combined together. I think in my project I combined the hoop with the original, so it was its own part, and then I combined it with it afterwards. So I don't really need this Boolean thing, so I'm going to just delete this one. But this one down here, the last one that we did, which subtracts this solid from the main snowflake, it says the part is missing because we modified the part. So it's not the original that we subtracted from. So you can just get rid of that missing part and just select make sure that's highlighted blue, and then you're going to select the snowflake again to resolve that issue. If you didn't have that issue, then great. Yours worked without that problem, but a lot of the kids in class had that. So here we go. So now we have our snowflake without the hoop. We've just modified that one thing, and now what we're going to focus on is creating an assembly. So the bulk of what we did last week is in this new environment called assembly, and in this workspace you would assemble parts. So this wouldn't make any sense unless you've already created some parts, which we have. And so in here there won't be any drawing tools. You can't draw lines, you can't extrude. That's all in the part studio. This is just meant to display the parts and how they interact with each other. So the first thing you need to do is insert some parts. So over here on the left, if I click the insert button, it will show me the parts that are available in my project here, and I have 2 different part studios, and if I expand that, there might be multiple parts or multiple solids in a studio, and I can select whichever parts I want to bring in. If you just want to bring in the main part and it's just one part, you can just simply click the whole part studio and then move your mouse away, and we're just going to on purpose place this somewhere random. So just going to click there to place it. And I'm going to focus on this for a while, so I'm going to go ahead and close this window by clicking the check mark. We're done selecting objects for now, so I'm going to click that check mark. And the first thing I want to do is attach this snowflake to the point of origin. so that it's stationary and it won't move. So to connect things, you're going to be using what's called a mate connector. So a mate connector is basically just identifying like a Velcro spot on your object, just so that it's easy to grab and connect to something. So I want to place one right here so I can link that. Actually, it's going to be at the bottom. So I want this to be hovering on the surface. So I'm going to orbit to see the bottom, just like that. I'm going to select this mate connector option and hover over my surface in the center of the bottom. So once you identify a surface, you'll get that little icon there, and it moves around with your mouse. And it's going to lock to different areas. So I'm locked to the correct surface. I know that because the Z is facing out, like up or down in relation to the object. And then the X and the Y are running along the surface. So I'm on the correct surface. This is the bottom surface. But I want it to be right in the middle. So that middle point is right here. So I'm going to click right there to place that. And right now the Z is facing down. And that may be troublesome to you. Maybe you want to have all of your Z's pointing up, indicating that, that's the upward direction. If that's the case, you can reverse or flip the primary axis. So if I click this, it's going to move the blue to be facing up towards the top. So when I orbit, there's the top, and my blue is facing the top. So now I have that mate connector right where I want it. My next goal is to attach that to the point of origin. So I'm just going to click the check mark. And the next thing, so we're kind of going from left to right in the tools here, is called a fastened mate. And this simply just puts two mate connectors together. So I'm going to click on the fastened mate, and then you have to have at least two things connected for this to work. So I'm going to select my first mate connector here, and then I want it to connect to the point of origin. And if you hover over the point of origin, you get that same icon, but if you rotate your mouse around, it moves to change orientation. So you want to make sure that it's the correct orientation with the Z pointed towards the top. So I'm going to, on purpose, change that and make it something different. So let's click here. See, as soon as I did that, it rotated my object to match that connector mate because the Z was facing off to the side. So I'm just illustrating the fact that you need to make sure that your mate connector is aligned correctly before you click on the position that you want to place it. So this is my second click. I'm going to click here. Now everything's lined up correctly. My Z is facing up, and it is attached to the origin. So I'm going to click the check mark. So this is just going to remain stationary, and I'm going to introduce my second part, which is going to interact with this. So I'm going to go back to the Insert button and then select the copy this time. The only difference is there's no hoop at the top, and on purpose I'm going to place it a little ways away. I don't want to overlap them so it's hard to see which one is which. I'm going to purposely place it off to the side. Then I'm going to close this dialog box here because I'm done placing objects. And now what I want to have happen is I want the two slots to line up with each other, so be pointed towards each other. So right now they're pointed in the same direction. I want it to be pointed the opposite way. So if I select my object, it will give me a navigation thing where I can transform based on the arrows, or these little circles are rotation. So you can rotate on either of the three axes. So sometimes you'll need to orbit to make sure you're rotating on the right one. So I want to rotate on this axis, like the hand of a clock. I want to rotate until they're facing each other. So it's going to be a 180-degree rotation. Then just click to accept that. So that's the one rotation there. But I need to rotate it one more direction because I want this slot to slide over this area. So it needs to be perpendicular. This will all make sense in just a little bit once we actually put the two parts together. So I'm going to click on that again, and this time I'm going to rotate this one to be perpendicular to the other one. So it's going to be a 90-degree rotation. And then just click to accept that. So they should be perpendicular to each other. Just like that. So what we're trying to demonstrate here is what it would look like if we take this second part and slide it in here all the way to the center. They're going to fit together like a puzzle piece. So we're going to create another mate on each of these where we want them to eventually connect, which will be right here on each one. So I'm going to create two fasten mates, or mate connectors, sorry. Two mate connectors. You may need to zoom in so you can get this exactly where you want it, but you want it right here. And I want the Z to be pointing towards the top, I think. So this one will eventually be pointing, let's just make them opposites. So this one is going to be eventually pointing toward the hoop. If I put the two parts together, the Z, the blue rod on here, is going to be pointed towards the top. So I'm identifying that sort of as a relative top to the parts. So I'm going to make sure that the other mate connector is pointed towards the top. So I'm going to click the check mark on this one, and I'm going to create another mate connector on the other part. I'm just going to zoom in to the same area. A little bit tricky to get in there. Right here. So I'm going to click on, so I have the one that's connected to the point of origin, the one that I just created. So I'm creating a third mate connector. It's going to be right here, but I want that to be the Z, again, I want that to be aligned, pointed towards the top where the hoop is. So I need to reverse or flip the primary axis. So that one's done. Click the check mark. So now I have two mate connectors identified that I want to put together. But the relationship that I want to have is one that slides back and forth. I want to demonstrate how the parts slide together. So I'm going to use what's called a slider mate, this one here, which will demonstrate that motion. So this mate connector needs two objects, or two different mate connectors. So I'm going to click on each one. There's one, and then this one over here. So as soon as I click the second one, it puts the two parts together. And I'm going to click the check mark to accept that. Oh, it doesn't like that for some reason. Oh, I selected the wrong mate connector. Okay. So let me get this one. So So I want to make connector 2 and make connector 3. So sometimes it's easier to select it here. So I'm just going to click the 2. Now that's nice and happy. Click the check mark there, and let's see the result. You should be able to grab the second part and slide it back and forth. Just doing this with my mouse. So click and hold on the object. You should be able to demonstrate how that will slide into the other part, just like that, all the way to the center. Now, it can go all the way through the part, which is not accurate to real life situation. So this would not be able to travel through if they were both solids. So the next thing we're going to focus on is creating limits on how far it can travel. So I'm going to get inside the slider options. So I'm going to double click, and there's some options here that I want to enable. I want to enable the limits, and the minimum is going to be set to 0. 0 is like 0 distance between the two. So it can't travel in the negative direction. So it can only go down to 0. That's the minimum. And I can leave it no maximum. Let's see what happens now. I'll grab the object. And, oh, it's still moving through. Okay, let's try something different. So maybe I need to click the check mark to accept that. And now let's try and see if it still does the same thing. Oh no, see it? That's what I wanted to have happen. In the real world situation, it could not slide past 0. Now some people in class were traveling in the negative direction, so it wouldn't work, like they could only travel in the wrong direction. So that's why we placed the 2 make connectors with the Z's lined up together. So positive on one part is the same as positive on the other part. So it can only go, you know, to 0 and then it stops. If you have issues with that and it's behaving the way you don't want it to be, you can reverse or flip the primary axis and see if that fixes it. See, that just flipped my object around, so that's not the right thing. The other thing you can do is go into your mate connectors and flip the primary axis on the part. See, now it's traveling the wrong way. It actually flipped it around again. But those are some things you can try to modify if your part isn't traveling in the right direction. If you do it the way I just showed you how, it should behave the correct way. So there we've demonstrated how these two parts go together in the assembly. There's one last thing that we want to I want to show you, and that this can automatically animate itself. If I right click the slider, I can choose animate, and then I have a play button here. This will play through the animation and it will loop continuously. The reason it's going so slow is because there's the number of steps is set to 300 steps. It's going to go through, it's dividing right now 25 millimeters worth of travel by 300 steps. So the way to speed it up would be to reduce the number of steps. So let's go down to 60 and see what happens. So now it's playing much quicker. So if I want to demonstrate farther amount of travel, I need to increase the end value. Right now the end value is positive 25. So if I want to travel beyond the edge of the first snowflake, I need to travel at least I think 75 millimeters. Actually, it'd be 150. So let's travel 150 and see what happens. So that's pretty good, but it's not far enough to demonstrate how the two parts completely separate. So let me go to 200. There we go. And it's traveling a little bit fast, so I can slow that down by increasing the number of steps. So let's go to 100 steps. So that's a really good fluid movement there. So the purpose of the assembly workspace is to show how parts connect and how they interact with each other. So that was the main portion of this week's lesson. So hopefully this all worked out for you, but the goal of this assignment is to have the two separate solids, one without the hoop, and then to place them both in the assembly workspace, and then have a successful animation showing how the two parts go together. So once you've completed that, that will be part of the grading of the assignment. Let me know if you have any questions.